Since Kaluza-Klein's pioneering work in proposing a five-dimensional spacetime, numerous theories have emerged positing the existence of extra dimensions beyond the 3 plus 1 spacetime framework. Notable among these theories are the large extra dimensions or LED model, the Randall-Sundermore RS model, and the n-particle model. How can we prove the existence of these extra dimensions? Each model postulates a hypothetical graviton which can propagate through the extra dimensions. Collider signals of this graviton would confirm the existence of EDs but would likely require extremely high energies to detect. Nonetheless, several experimental searches have been conducted at the Large Hadron Collider, primarily probing for graviton emissions and resonances through its decay into standard model particles. However, each model's graviton has different spectra and signatures, which may imply that one model's graviton could be more easily probed by collider experiments. We compared the different ED models using various HEP tools in order to simulate production processes involving the graviton. The jets from the gravitons manifest distinctive features as shown through their kinematic variable distributions. These variables are transverse momentum, which is the component of the momentum perpendicular to the beam axis observed from the xy plane. The azimuthal angle is simply the angle between PT and the x-axis. It provides information about the angular distribution of particles in the transverse plane perpendicular to the beamline. And pseudo-rapidity is the angle of the jet beam with respect to the beam axis. And lastly, the invariant mass is the particle's mass before it decays. If two jets originate from a particle decay, the dijet invariant mass will correspond to the mass of that particle. To better describe the transverse momentum, azimuthal angle, and pseudo-rapidity, we can picture the collider as a kind of cylinder where the height corresponds to the z-axis or the collision beam axis. The xy plane or transverse plane is perpendicular to the x-axis, akin to viewing it from the top. The azimuthal angle is then in the xy plane, while pseudo-rapidity then considers the polar angle of the jet beam with respect to the beam axis and is in the yz axis given by theta. These distributions are then compared according to their ED model and the role of the graviton in the production process, whether as a final state, a propagator, a mediator, or part of a trijet process. Cross-sections of the production processes were also plotted to show the probabilities of the processes occurring at those parameters. In this way, prospects of reactions involving gravitons are probed for higher collider runs not just at the LHC but also for future colliders. Since each model's theoretical framework varies significantly, it is helpful to determine which model is most experimentally promising.